Hi there, and welcome to RECOM's Powerful Podcast, where we discuss new topics and products. I'm Jeff Deutschman, your product moderator. From a quarter watt up to 1,000 watts, whether the power is required for an industrial setting, a new IoT gadget, or a high-end medical-grade device, RECOM has you covered. On this episode, we're going back to the basics. We'll be discussing a few datasheet parameters that are common for our portfolio. Peter, what can you tell us about this stuff?
Yeah, that's right, Jeff. So I think this episode will help newer customers interpret the datasheet better and will serve as a good refresher for our veteran customers.
Is there a particular specification you'd like to start with?
Yeah, the first one I had in mind is the max capacitive load. So oftentimes customers will implement capacitors on the output of our parts for filtering and to help reduce the ripple and noise.
And what's the danger of having too much capacitance?
So when power is first applied, the caps act like a temporary short circuit and will draw in a lot of current. So this current will pass through our parts as well, so we need to make sure it's not too high.
Or else the power supply could be damaged, correct?
Yep, that's exactly right, Jeff.
You also mentioned ripple and noise. Do you want to talk about these further?
Yeah, of course. So all of our parts are switch mode power supplies, meaning there will be a small level of voltage variation on the output. We typically provide this spec in millivolts, peak to peak, and that's limited to a 20 megahertz bandwidth.
And what's the best way to interpret the bandwidth spec?
So this is known as the cutoff frequency. So the peak to peak voltage on the datasheet is only relevant for frequencies below 20 megahertz. Anything above this would require further tests and evaluation.
Great. Speaking of high frequency noise, the datasheets also have EMC filter suggestions, correct?
Yep, that's right. And these would help filter out those higher frequency noises we just talked about. So we usually offer Class B filter suggestions. These are pretty simple, usually consisting of a couple capacitors and inductors.
Okay. And where are these typically located on the datasheet?
They're usually towards the bottom after our EMC compliance section. This section will also let customers know if any external filtering is required at all. So some parts, like our new AC to DCs, don't need these extra components.
Excellent. Any other parameters you'd like to discuss?
Yeah, let's talk about the derating graph.
Fantastic. These are the load versus ambient temperature graphs, correct?
Yep, that's right. So I'll use the REC15E-C as an example. So if anyone listening wants to pause and find the datasheet, you can follow along. So as you can see, this part can output 100% load from minus 40 degrees C all the way up to 75 degrees C. When the temperature exceeds that 75 C, you'll need to derate the power.
Got it. And that's to prevent the power supply and internal components from overheating.
Yep, that's it. So it's a trade-off, right? We can operate at higher temperatures, but only with lighter loads. And I'd like to point out that most of our parts are not equipped with over-temperature protection. The derating graph doesn't mean that at 85 C, the part will automatically adjust to 70% power. This is something that should be considered by the designers.
Very helpful, Peter. Thank you for sharing. Well, that about wraps it up for this episode of RECOM's Powerful Podcast. Be sure to listen next time when we delve into the pros of another RECOM topic. As always, please contact your regional sales manager for any samples or pricing information. Our application engineers are always happy to assist you with any technical questions or requests. You can email them at techsupport@recom-power.com. Until then, have a great day, and always remember,
RECOM powers your products.